The difference is an equal sign. And again, we're going to start off easy because we're going to show you just how easy this can be. The first one, no fractions at all. So just solve for x. I'm going to subtract 2x from both sides. That gives me 2 is equal to x minus 4. I'm going to add 4 to both sides. And I get 6 is equal to x. Easy. We've been knowing those for a long time. So all we're doing is getting x by itself. It's a basic, simple equation. We move anything with x to one side, anything without x to the other, and we solve x is equal to 6. Easy questions. Remember I said math is all about trying to make things that look complex be easy. So if we can take something like this and make it look like that, our lives will be a lot easier. That's what we're going to do. And there's a trick that makes it pretty easy, and it's a pretty easy trick to remember. So, we've got this. We know that fractions can't be added to other things unless they have a common denominator. So these all have to have a common denominator of 4 if we were to be able to combine them. Yeah, so that's what we're going to do. We're going to just times 3 by 4. So it's going to give you 12 over 4. All I did was I times that by 4, and I times that by 4. Because we wanted a common denominator, right? So I times the top by 4, and times the bottom by 4. So remember 3 is the same thing as 3 over 1. Right? So if I times the top and the bottom by 4, that's how I get 12 over 4. Soccer.
Well, I keep times everything by 4. So
do this. Hi. Just trust me. I know where we're headed. You're right. You can times everything by 4 and move on.
You know how you like take something out?
Where did the 7 go?
Okay. Restart. So we've got a fraction. We can't add fractions without common denominators. Good. We're remembering where we're headed. So the 3 is the same thing as saying 3 over 1. Correct? Okay, we want to get that a common denominator of 4. So we multiply the top and the bottom by 4. The 7 is the same thing as 7 over 1. We want it to have a common denominator before we do top and bottom by 4. So that's what we're going to change these things to. So it becomes x over 4 plus 12 over 4 equals 28 over 4. All I did was I gave everything a common denominator of 4. I understand that there's other ways you could solve this question because it's a really basic question. When things get more complex, you'll need to know you get common denominators. Good. We're good? Okay. Beauty. When you get a common denominator for everything, and you have an equal sign, you can forget about all the common denominators. They all cancel each other out. So, it's now just x plus 12 equals 28. That's the trick. If you have an equal sign, and all common denominators are the same, you can get rid of all the denominators. Time. There's a reason, no, they don't go anywhere, they're just gone. They don't have to show up anywhere. The reason they're gone is because I've basically done what London was trying to say. If I have an equal sign, how would I undo this divide by 4? I'd multiply everything by 4. But because everything has a common denominator of 4, when I multiply everything by 4, they all cancel out. And that's why they all go away. Right, guys, you got a question?
What
Then just like kind of put your hand down. Okay. So they just go away. Now it's an easy question. Move that 12 over, and x is equal to 16.
We just moved 3 over right away.
So, like I said, I understand there's other ways you could have done this question, because it's very easy. Yeah? What you did is right, not wrong. I'm just saying, this is a basic question. I'm trying to get you to understand. Common denominators don't cancel out. You're not wrong. But you're not going to get a question like that. Ever. You've been doing questions like that for years. That's an easy question. I'm just showing you a new way to do it. It's going to be very useful in a little bit.
Okay.
When our denominators start to become x plus 1 or 6x squared minus 8x plus 3. You'll want these strategies. And I'm using easy numbers to show you why it works. Okay, let's look at this next one. We've got fractions. You can't add fractions unless you do what? Common denominator. What would your common denominator be for this one? 12. So you're going to try to get everything to have a common denominator of 12. This first equation, how would I get it to have a common denominator of 12? Multiply it by 4. This second one, what am I going to have to do to get it to have a common denominator of 12? Multiply by 3, because that's what it was missing. And the last one, I'm going to multiply by 12, because it was completely missing the denominator. Now, every one of these is 4m over 12 plus 9m over 12, and it's equal to 156 over 12.
Wait.
You have an equal sign. You have all common denominators. What can we do? Get rid of all the denominators. Times everything by 12. All the denominators go away. Now you have 4m plus 9m equals 156. That means 13m equals 156, which means m is equal to 12. Easy. It's easy. This is your nice little note sheet. If you have no idea what the heck happened, maybe reading it through some nice instructions will help. Number 4. Now we're going to start using variables on the bottom. So things are just going to get a little bit more difficult. But nothing has changed. You have fractions. What do you have to do if you have fractions? You need a common denominator. You need to make them the same. So, what's our common denominator going to be? 4x. Beauty. So, what do I have to do this first one to get it to 4x? Times it by 2. What about the second one?
Times it by x.
You're going to times it by x. What are you going to do to the last one? Nothing. It's good. So now you've got 10 over 4x plus 3x over 4x is equal to 9 over 4x.
Over 40.
Hi.
So I need to show that everything in one x, right? Because I found a common denominator as one fraction.
Yeah. If you are at the point where it's like, oh, I get it, there's my common denominator, I don't even need to write it, then you can start just not writing it. Yeah. You can skip the step of taking it out. You just take it out in this step. Yeah, that's okay. What do you do right now? Get rid of all the 4x's. They're all gone now. Right? Denominator goes away if they're all the same and you have an equal sign. Now just solve it. Move the 10 over. So you have 3x is equal to negative 1. X is equal to negative 1 over 3rd. Good point. It's asking for x. It wants to know what x is. So x is 1/3, negative 1/3. But you do bring up a good point that we have to look at now. We were dividing by a variable. So that means there's non-permissible values somewhere in this equation. What are your non-permissible values? 0. Why is it 0, Dante? Exactly. If you look back to the beginning, you can't divide by 0. 4 times anything that's a 0 would be 0. So x can't be 0. In this question, is x 0? No. It's negative 1/3. So your answer's good. If it wasn't good, that's when you would have an extraneous root. Remember that? Exactly. That would be a solution that wouldn't work. Okay, let's try this next one. What's my first thing I need to do? Common denominator. What's my common denominator going to be? X squared. How am I going to make that first thing have a common denominator x squared? Multiply it by x squared. What about the second thing? Multiply it by x. What about the third thing? Don't do anything. So we have 3x squared plus x is equal to 4. If you have an x squared term, you have a quadratic. If you have a quadratic, you flash back to that terrible time in October when we just solved quadratic.
No, like 1 over
X. So 1 times x is x.
x over x.
And the common denominators were all x squared. They all went away. Sorry, I skipped that step.
I was so lost.
If you have a quadratic, you move everything to one side and make it equal to 0. So 3x squared
But I thought
plus
we were
x.
supposed to like make it imaginary denominator for the before we were saying
It would have been 3x squared over x squared. I skipped that step. So I skipped the step where
Oh, yeah.
I got rid of all my denominators. You could use quadratic formula. You could also see if you can diamond method it. Things that multiply to be negative 12 and add to be 1 are 4 and negative 3. So you can factor this nicely to just be 3x. I diamond method it. Plus 4 times x minus 1. If you just diamond method, that's what you get. No? So what is x? Time. X is equal to negative 4 over 3 and 1. What are your non-permissible values? X cannot equal 0. So all of our solutions are good.
When you do the quadratic, you put it in your calculator like in a square root form, and then it comes out to 3x.
Yeah, whatever you get will be x. Like we do the whole formula, not just what's in the roots of it. Yeah, the whole thing.
Do you use the both your plus and minus answer or just plus?
Both. The plus answer would have given you 1. Minus answer would have given you negative 4 over 3.
What difference between both are this and that?
If they were left in quadratic formula form,
Yeah.
if you can simplify, keep simplifying. I know before we were leaving answers like that, but that's because it was like 1 plus or minus root 3, and it's like you can't do the root 3. That's the only reason we were leaving them like that. They'll work out now. Alright. 2 questions. Give her a go. On your own. I'll put the answer on the board. You can check your answer with my answer. So, first one, people seem pretty happy with. Yeah? Okay, second one, seems like it caused a little bit of issues. And most people got to this stage that I'm going to highlight in blue just fine. Most people got there okay. What a lot of people didn't do was my next step, which is where I moved these things to the right. A lot of people moved this one thing to the left. So you would have had negative 6x squared plus 5x plus 6 equals 0. Yeah, and that's fine. You can have that. And if you factor it properly, you'll be good. You'll get the same answer. The problem is if you have a negative a value, it makes things really difficult. And there's a lot of little things you need to remember if you have a negative a value. So you don't want a negative a value. So if you're at this point in red, negative 6x squared minus plus 5x plus 6 equals 0, and you see you have a negative a value, instead of trying to factor that, which is doable, it's just more difficult, change every symbol. So make that positive, make that negative, make that one negative, and then factor that. It'll just help. All you've done is you've multiplied everything by -1. You could also do it at the very end if you wanted to just change your answers around. There's no difference. Yeah, so it gets you in the same spot. Why on earth? Like, holy moly. Zucker.
Yeah, I'm going to get it like negative.
Like you did my way. Yeah, you get the same answer. Yeah, and it works both ways. That's what I'm trying to say. I'm trying to help people and let you know if you have a negative a value, switch all your signs. It'll make your factoring life easier. If you don't, fine. I suggest you do. Or whatever. Okay. This. A lot of you have been asking for this. It's a way of checking your answers. A lot of you have been taught this. If you know it, great. I'm not going to teach it. I'm going to provide you with the info if you wish to learn it, but I'm not going to teach it because people just get confused and it makes things tough. It's a lot of calculator work. And at the end of the day, I'd rather spend time learning how to do this stuff than learning how to check my answer through my calculator. So if you don't want to do that, that's fine. You can put a big X through that slide if you never want to have to use your calculator. This won't solve anything for you. It'll just check your answer. So you still need to know how to do it. It just checks your answer. So you're not missing out on anything if you don't learn it. This. Why is this harder now? Yeah, because the bottom's no longer just a one thing, it's multiple things.
So am I actually solving for something, or am I solving for an expression?
You're solving for x. Yeah. So now that you have an equal sign, your answer should always finish with x equals something. Always. That's why we have equal signs. You actually define something. So, what makes this harder? Leonard said, well, if you look at the bottoms, like these things are actual statements. So we're going to do Dawson's first step. Add brackets. Nailed it. If you add brackets, it makes things easier. Because now you will remember that's one thing. It's whole. That x plus 4 together, that's 1. X minus 2, that's one thing. So what would your common denominator be? X plus 4 times x minus 2. That would be your common denominator. So if you're looking at the first equation, what am I missing to get my common denominator? I'm missing my x minus 2. How about for my 3? I'm missing my x plus 4. My denominators will wipe themselves out because they'll be the same now. So the denominators are going to go away. I'm going to write it out anyway. So I'm going to go, remember when we multiply things, we do the top and the bottom. So we would have 5 times x minus 2 divided by x minus 2 times x plus 4. Just give me 1 second. You have 3 times x plus 4 divided by x minus 2 x plus 4. Yeah, you're going to multiply that 5. I'm just doing 1 second. Common denominators and an equal sign. They go away. The denominators go away. The 5 distributes in, so it's 5x minus 10 is equal to 3x plus 12. And the denominators are all gone. Now, you're back to the very original first type of question you ever did. And that's easy. You guys have been solving that for years. Move your 3 over. So now you have 2x on the left. Move your 10 over. So now you have equals 22. That means x is equal to 11. Is x allowed to be equal to 11? Go back and check your non-permissibles. X can't equal -4 and 2. So we're good.
So if it didn't work, then that means like
Or there's no solution.
If you,
like say you could x could be 11 and you got 11, so that you could just
Nope. It just meant that that's not a solution, an extraneous root. Because remember we've done this, we did that all in unit 2, 3, where you get those, sometimes you can get an answer that's extraneous.
Your answer wasn't.
Yeah, exactly. Okay, this next one. Now, you could do the trick that we talked about a long time ago, and I think it was CJ who said that, well, just multiply that one over, that's your common denominator every time. He's right. No wrong fault in that. It'll work. But it makes it hard. What makes it easier? Put it in brackets. I'm happy with that. Someone said it. Factor it. Factor anything that can be factored all the time. So we're going to factor that thing on the left. That's a difference of squares. You could square root the 1 and get 1. So this thing on the left is actually x plus 1 times x minus 1. It's the difference of squares. And the reason it works out so nicely to factor is what would your common denominator be now? X plus 1 times x minus 1. The first one already has your common denominator. So you don't have to change it at all. You just have to change the one on the right. If you didn't do that, you would have got a really big thing, and it would have sucked, right? You would have been factoring a couple more times, and it would have had a few more cancellations, and it would have been a lot more work. If you factor first, save yourself later.
The way you would have just canceled out the 2x plus 1. The way it splits.
Well, and see, and that's when you run into problems, because you don't want to cancel things out. Right? We're not trying to just work with it, simplify an expression. We're trying to solve for something. So yeah, you would have got these two things up here, right? But we don't want to cancel out, because if you cancel out, now the denominators aren't the same. And if the denominators aren't the same, you can't erase them. You see what I'm saying? So that's why that runs into trouble. Factor first, save yourself later. That's the lesson in this. What's my common denominator going to be? X plus 1 times x minus 1. The thing on the left, what do I need to multiply that by? Nothing. It's good. The thing on the right, what do we need to multiply it by? X minus 1. Let's multiply the right by x minus 1. And all the denominators will go away. Yeah.
How does the x minus 1 go away though? Like, what's its common? Oh, never mind.
If we're not, I see the confusion a little bit, is because we want to cancel, right? Like we've been saying, well, that cancel there, and that's beautiful, and then we add them together. But we're working with equations now, right? So we can use the trick to just get rid of the denominators altogether.
So it's like adding, you can totally get rid of it, like multiplying, you can get rid of top bottom, and then total, you can get rid of all.
Exactly. If there's an equal sign, you can get rid of all the bottom. So now we just have 3x plus 1 is equal to negative x squared plus x. I just multiplied that thing in. That's all I did. To solve that, it's a quadratic. So get everything on one side, so it's equal to 0. So move these two things on the right to the left. And the reason I'm doing that is because it gives me a positive a value. So I'm going to have x squared plus 2x plus 1 equals 0. I'm going to diamond method the thing on the left. It's x plus 1 times x plus 1, which is a silly way of writing things. It's just x plus 1 squared. If you wrote it like that, that's fine. What's x equal to?
X doesn't equal anything.
X equals negative 1.
X doesn't equal anything.
Just wait. Everyone. X is equal to negative 1. Now what do you check? We know non-permissible values. So go back to the beginning. What can x not equal? It can't equal negative 1 or 1. So this is an extraneous root. So you put there's no solution.
Wait, bottom is x squared minus 1. Oh, yeah.
Factor it.
Yeah.
You just do, would you diagnose solutions or extremes?
It would depend on the question on what your answer would be. So, if the question was, what's the solution? You put no solution. If then, how many solutions are there? There'd be 0 solutions. If the question is, are there any extraneous roots? You say yes. The extraneous root is x equals negative 1. So it all depends on what the question's asking. There are no solutions. There is an extraneous root. And whatever it asks you, that's what you have to answer. Two more. Make it happen. I'll put the answer on the board. Thank you. So it's x plus 2 times x minus 3 is the common denominator on the first one. So you need to multiply the first one by x minus 3, and you need to multiply the second one by x plus 2. That was my result. I then brought everything to one side. I brought it to the side where my a value is going to be positive. I then factored. Those were my answers. I checked my non-permissibles. They all matched up fine. So we're okay. Over to the second one. Same thing. What's my common denominator going to be on this one? X minus 1 times x minus 5. The x minus 1 is missing on the left side. The x minus 5 was missing on the right side. So that's what I multiplied each one by. That was my result. When I moved things over, it actually worked out quite nice. The x squares cancel each other out. That's always nice. A lot of people have an answer of 1 over 3. That's the same answer. That's right. If anything, it's a more proper answer, so that's good. If you check your non-permissibles, they're 5 and 1, so our answer checks out, so we're good. Last step. Now we have trinomials. It's no harder. Yeah, just factor them. Again, you make everything easier, right? So if you have a trinomial, it'd be easier if it was binomials. So change into binomials. If you had binomials, it'd be a heck of a lot easier if they were monomials. So we put them in brackets. Make them 1 each. Then it'd be a heck of a lot easier if those fractions just got rid of themselves. So that's what we do. And we just keep progressing like that. Yeah, that's what we're saying. Yeah, back to the trinomial. It makes your life so much easier. Trinomials look harder. Turn them into binomials. Factor it. So, the thing on the left is going to still be x over x minus 3. I didn't put those in brackets because that's what Dawson told me to do. It's equal to negative 6 over x. Yeah. X minus 3 and x minus 5. We diamond methoded that. The plus side of doing that is now you know what your common denominator is going to be. What's it going to be? It's going to be x minus 3 times x minus 5. The one on the right already has that, so you don't have to change it. You do have to change the one on the left. Multiply it by x minus 5 on the top and the bottom. The bottoms will all cancel out, and you'll be left with x times x minus 5 is equal to negative 6. FOIL that. X squared minus 5x equals negative 6. Bring that negative 6 over. X squared minus 5x minus 6 equals 0. Things that multiply to be 6 and add to be negative 5. Negative 3 and 2. So x minus 3 times x minus 2 equals 0. X equals 3 and x equals 2. Then what do you have to go check? Non-permissible values. Where do you check for non-permissible values? The first time you had everything in factored form. So up here, x can't equal 3 or 5. Maddie, what's up?
I have my x to negative 3 plus 2 is negative 1, not negative 5.
Negative 3 plus negative 2.
Oh.
They're both minuses. So was 3 an answer? No. So your final answer would just be x equals 2. Adding an equal sign makes it easy, I think. Right? Like there's no craziness. We're not combining things. Things just cancel out. It's kind of nice. Now all the skills are the same. Find a common denominator, FOIL, factor, all the same stuff. This one, a little more complex. How are we going to solve it? Step by step. Factor. Factor this thing on the right. Someone asked me in the last class, can't they combine these two fractions? Find those two first, combine them, and then do that? You could. It's going to create a lot more work for yourself. My suggestion is find a common denominator for all three right off the bat. And that'll be easier. So factor that thing, and you get x over x plus 1 is the first term, minus x plus 1 divided by x minus 4 is equal to 5 over x minus 4, x plus 1. Colton, Josh, Ryan, can you guys just stop whatever the heck you guys have been doing for the last half hour? Okay, but you guys have also been looking at the roof. You've also been looking at whatever the heck Colton had earlier. Josh has been rapping. Like, see how nice that is? What's our common denominator going to be? X minus 4 times x plus 1. That's going to be our common denominator. The thing on the right already has it. So we don't have to change the thing on the right at all. The thing on the left, we do have to change. No, it won't always work out where it's like that's going to always, no, yeah. It's nice when it does, but it won't always.
It will in practice.
Yeah, it will in life. Okay, So what do we have to multiply the first fraction by? What's it missing? It's missing an x minus 4. So we have to go x times x minus 4. What's the second fraction missing? It's missing the x plus 1. And it's all equal to 5, because we didn't have to do anything to that side. FOIL, we're going to get x squared minus 4x minus, put it in brackets, x squared plus 2x plus 1 equals 5. I put that in brackets because you need to remember that negative goes to everything.
A quick question.
Yes.
Why are we, if we found a method to get it out, how can we, or,
Like right now?
Yeah.
That's a great question. And the only reason we do that is because we can't combine these two things unless we find some like terms.
oh,
So by foiling it out, we'll find like terms, and then we can work with it. So that's a really good question, Doctor, because it's kind of backwards thinking. Right? Why foil all the time? Why factor if we're just going to foil back out? That's why. We can't combine these things without doing that. I put brackets around this because that minus sign applies to both of these. So when these things foil out, that minus sign has to apply to all three things that I foiled. So all the symbols are going to change. So now you have x squared minus 4x minus x squared minus 2x minus 1 equals 5. All the x squares cancel out. You get negative 6x. I'm going to bring that 5 over, so it gives me negative 6x minus 6 equals 0. I brought 5 over, so I subtracted 5 from both sides. So right here, minus 5, minus 5. X squared minus x squared. Cancel each other out. Remember that this is a negative 1 right here. So x is equal to negative 1. Right?
I don't like it.
I get it. X is equal to negative 1. And why can't you have that, London?
Because x plus 1.
Check your non-permissibles. X can't equal negative 1 or 4. So no solutions. Is there an extraneous root? What's the extraneous root? Negative 1. There's no solution. Question. Before we move on into the next part of this unit, which is graphing.
Really?
Yeah. How can you get no solution? So what would that mean on a graph when you have no solution to something, Zucker?
there's no, that is intersects.
Yeah, it means there's no intersect. So that's what it means when you find no solution. It means this thing won't intersect that thing. Yeah, you could. Yeah. We're not going to be graphing these things. We're graphing something else. We're going to graph new types of functions and we're going to focus on something else completely. But we're going to, instead of complex things like this, we're going to graph things like just that, more basic. So, because these graphs do some crazy things right now. If you go to a Math 30-1 class right now, Shop teaches it right after lunch, and they literally, I think, did this exact question. Like, this stuff leads into 30-1 and 30-2 just perfect. Like, this is a pretty critical unit. They did what we did because it has to do so much with their graphs. So they have to be able to do this to be able to do the graphs that they want to do. which sounds kind of confusing, but it makes more sense when it's there. Okay. There's your multiple choice question. You got a couple minutes to answer it, and then I want to do one more question. So go ahead, solve it on your own. Wait a second, try to solve that one. If you found your common denominator, it had to be x plus 3 times x plus 6. Multiply that one by x plus 6, that one by x plus 3. You factored it out. You should have got, that was your answer. Ty, want to come show the world how you did it? No? Have faith, Ty. Why not? It's okay if you messed up. I'll protect you.
It's going to be like a separate category.
Okay.
That's actually not here.
Wait, listen to Ty. Ty has a quick solution to this.
You know, you see your values of, okay, you see how these equal each other, yeah? That means literally these equal each other. So what numbers you plug in here to there should equal the exact same. Does that make sense?
Why are you looking directly at the
Do it. Oh, touch it. And do it. Do -4. Prove that -4 works. That's okay. It does work. I wouldn't say it. It's just absolutely super beautiful.
You have to first.
So he's subbing in -4 for x. And if his hypothesis is true, it means he should get two numbers that are equal. If he comes out and it says 6 equals 2, that's obviously not true. So that's obviously not an answer.
Honestly, I did all the work.
Boom. Hey, that does work. And occasionally on a test, it does work also. And occasionally on the diploma, it does work also. So it's a nice little trick to have in your bag for when you don't know what to do. Because it will work. Really. Okay. Before we do that, and before we pack up,